Hi, in the last video we discussed about how do we test the hypothesis for mean when the population variance or the population standard deviation is given and the other case was not given. Okay, and I showed you how to do by hand by two methods, p-value method and the critical value method or the traditional method, and also I showed you how to do by using R software, just one line code, right? So we did. So in this video I'm going to show you how to do the hypothesis testing using R and by hand for the proportion and the variance. So again, you saw these things in the statistics class. This is just a review, okay guys? So for a proportion, all the steps are same. Only the difference on these steps is the test value formula is a little bit different. The test value formula for the proportion is T equals to P hat is sample proportion minus P is the population proportion divided by standard error, right? So PQ over N. That's what you see there. Okay. And then the p-value method exactly the same that we did in the for the mean when the sigma is given, and the decision is also the same. Okay. So let us do one example. A researcher, let me write down the given things here on the corner there, right? A researcher claims that based on the information obtained from CDC, 17% of the young people ages 2 and 19 are obese. Okay. So what is given is P is 0.17. That's what the population proportion given there. To test this claim, somebody wants to test the claim. She randomly selected 200 people ages between 2 and 19, n equals to 200, and found that 42 were obese, so x equals to 42. And use alpha equals 0.05 and alpha equals 0.05. Is there enough evidence to reject the claim? Can we reject the claim? The claim is equals to 0.17, right? P is equals to 0.17. Can we reject it, meaning that it is two-tailed? So alpha is 0.05, two-tailed. That's what we can say from the question. Okay, now what we want to do is we want to write all those steps. I'm showing you how to do by hand here. Okay, so here h sub 0 is, this is for the proportion p equals to 0.17, so it is two-tailed, so p not equals to 0.17, right? Now what do we do next is you just plug in. What is x hat though? So x bar, let me find out that x bar here, sorry, x hat is not x hat, p hat, right? So p hat is x over n, that is 42 over 200, right? That is 0.21. So 0.21 minus 0.17 divided by, you get under the root, what is p? 0.17 times q is 1 minus p, right? So q is 1 minus p. 1 minus p will be 0.83, right? Divided by n is 200. So the whole denominator is under the root. Okay, so this is the standard error. Okay, so find out that value. What is that value there? So you want to find out 0.21 minus 0.17 divided by under the root 0.17 times 0.83 divided by 200. To find out this, oh by the way, so this should be G not T. We did not, I mean you can denote by test value as like uppercase T, that's perfectly fine. Okay, but usually for the test value for the proportion we denote by lowercase g. Okay, so let me use R to find out that value. How much is that? That will be 0.21 minus 0.17, right? And then divided by, since there is a root, so what I'm trying to do here is square root sqrt, calculate the square root. P is 0.17 times 0.83 divided by n is 200. Okay, so if you do that, what do you get? If you hit enter, you get 1.5059. That's what I got, 1.5059. So this is two-tailed test, right? So this is two-tailed test and this value is positive, it is on the right side. So p value is p equals to 2 times area right of the test value z. That means So you will do 2 times the area right of that. So how do I find out the area right of these? So there is 0 there. So see, how do I find out that area right of that? 1.5059. So to find out that, so we will use R for that. So P equals, so P will be, so it will be P norm 1.5059 and then 0, 1. What does it calculate? It calculates the area left of that, right? So if you do 1 minus, it will find out the area right of that, but we need to do 2 times, so that will be 2 times that, right? So how much do you get? You will get, so you will get 2 times, and then inside the parenthesis 1 minus P norm, right? And 1.5059. Is that what we got? Yes. 505059. That's what you got. And if you hit enter, if you hit run or enter 0.1320, that's what you get. That is 0.1320. That's what you get. Okay, guys. Now, so what is the decision? Is the p-value greater than alpha or less than alpha? Our alpha is 0.05. Since P is greater than alpha, we do not reject, right? We do not reject 80. So what was the claim in the problem? The problem is showing that the claim was, is there enough evidence to reject the claim? What was the claim? To test this, a researcher claim, okay, the researcher claimed that the obese percentage is 17%. So this is the claim, right? This was the claim. So is there enough evidence to reject the claim? The answer is no, because we don't reject the 80. So hence there are not enough evidence to reject that the percentage of obese kids or people in the age group 2 to 19 is equal to 17%, right? 0.17 or let's say, because we said the percentage, so I would say 17%. Okay, so this is how you write the conclusion. Okay, let me do this thing by R. See, it took the whole page, but you need to know how to do this by this method too. But if you want to do by R, it is a prop.test, and x equals to 42. That is x equals to 42, n equals to 200. Confidence interval is 95%. So confidence level. So conf level means confidence level is 1 minus alpha. Okay, alpha is 0.05. So the confidence level is 0.95. You see that? And what is P? P is basically the null hypothesis. P is equals to 0.17. You can put that P right at the beginning or anywhere you want to. It will give the same result. So alternative hypothesis is two-sided, right? This is two-tailed or two-sided. So let me erase whatever I have there, and then I will run that code, this line 123. Let us see that. You see that sample estimate, meaning the sample proportion is 0.21. That's what we got here. And then so the null hypothesis is 0.17. You don't have to worry about that. Look at the p-value. The p-value is 0.158. So this the R uses a slightly different method, because there are different ways to do the hypothesis testing of the proportion. Okay, so we are using this method, but and again another thing is how many decimal places you take here. Okay, because there is a root that may be never ending decimal there, right? So it depends, also depends on how many decimal places you take, as well as as well as the method it used. Okay, and what I did is I found that p-value 0.1320, here the p-value is 0.15, but still both of these p-values are greater than alpha, right? So we do not reject the null hypothesis. So basically the conclusion and the decision are not changed, but the p-value are a little bit different, but we are okay. Okay, guys. So this is how you find out the proportion, the test the hypothesis for the proportion. Okay. So the next one is the testing hypothesis for the variance and the standard deviation. So how do you test the hypothesis for the variance? So all the steps are same. Alright, the next one is testing the hypothesis for the variance or the standard deviation. All the steps are pretty much the same. Only the difference is for the test value we denote by chi-square, right? And the formula for the chi-square is n minus 1 times s square over sigma square. What is s square? It is the sample variance. And sigma square is the sample, population variance. Again, if you are asked to test the hypothesis for the standard deviation, what we do is we test the hypothesis for the variance and then we use that result to the standard deviation. Okay, and to find out the p-value we will have to do p chi-sq in the r. Okay guys, all right, so let me basically do this example here. What it says here is, look at this. This is the R code. Okay, R code for the variance test. We do VAR dot uppercase TEST, where the data is that data you enter. Okay, and then sigma squared is the given variance. Okay, or the null hypothesis. Sigma squared is null hypothesis. Confidence level is just 1 minus alpha. Alternative is left tail, right tail, or two tailed. Okay guys, so let us do this example. Okay, first of all, let us read the question. Listed below are the way of 15 randomly selected. So what is the n? N is 15, right? N is 15. Selected bumblebee bats. That's the world's smallest mammal. Using 0.05 significance level. Okay. So alpha is, significance level is alpha. Confidence level is 1 minus alpha. Okay. So the alpha is 0.05. That's given. Test the claim that the way come from a population with a standard deviation sigma is 0.30. Sigma equals to 0.30. That is the null hypothesis given, but we always test for variance. Okay, so we do sigma square. What is sigma square? Sigma square is 0.3 square. Okay, so how much is the 0.3 square? That is 0.09. So what we write the null hypothesis is variance is 0.09, and then it says come from a population standard deviation equals to 0.30. That means, so it doesn't say less than or greater than, so it is a two-tailed. Okay, so sigma square is not equals to 0.09. Okay guys, now what I'm going to do next is I want to find out the standard deviation of this data set. Okay guys, so let me enter this data set in R and then find out the standard deviation of that data set. Okay guys, so that is the bat weight is the data. So what I want to do there is standard deviation, okay, of the bat weight, bat and then weight. Okay, so let me run this guy, and then that one I got 0.2587. That is the sample standard deviation. That's what I got. So it is S is equals to 0.25 and then what was that? 8. Let's do 8 when you round it up. 0.2588 is S. So what will be the S square? So you will do the square of that, right? So I will do that. So N is how many? How many data points are there? So there are, let's count that, 1, 2, oh there are 15, right? Because it says 15 randomly selected. So 14 times S square is 0.2588 square divide by, you got sigma square is 0.09. You see that? That is 0.09. That is the sigma square. Okay guys, now what will be that value? I want to put that in R and then find out. So that is 14 times 0.2588 square divided by 0.09, because this is already, you don't have to square that because this is already sigma square. it was s, this value was s, and then there was s squared, so I squared that. But this is already sigma squared is 0.09, so I don't have to square it. Okay, so don't get confused on that. And then let me find out that value, 10.41871. So that's what I got. This is the 10.41871. Okay guys, so this is the two-tailed test. Okay guys, so what I am going to do here is I want to find out the p-value is 2 times area left of this number or right of this number, depending on where this falls. Does this fall on the left side or does this fall on the right side? We don't know it, right? Because all the value of the chi-square are positive. So this may fall here, around somewhere here, or somewhere here. We don't know. How do I know that? Is you can try to find out the area using R, using the p chi-sq. Okay, so you do p chi-sq. So if you do p chi-sq, and then what is the test value? It is 10.42. Let's say that. And then what is the degrees of freedom? It's 14, right? 14 degrees of freedom. If you do this, oh, by the way, there is 2 times, right? 2 times. So P is the probability, so it cannot be bigger than 1, okay? So since we don't know whether this 10.42 falls here or here, okay? So what we can do to test that is, if 10.42 falls here, because the P chi-sq find out the area left of that, right? If this is the 10.42, so the 2 times the area left of that will be more than 1. Okay, in that way we will know that this falls on the right side. So if this area is less than 1, then we will think that, oh, that value fall on the left side. Okay, so let me find out that. So it will be 2 times, p chi-sq, and then 10.42 comma, and then 14. When I find out this is 0.5382. So this value is 0.5382. That means what? So this value falls on the left side. Because see, you can think that like this may be some of the half line, right? Right. So 2 times the area left of this, right? So you can think of that 2 times the area left of this. This is the area left of that. If you multiply by 2, then you get 0.5382, right? So we are okay. So this is that chi-square value. That is that test value chi-square. It falls on the left side. Okay. So you got 0.5382. Okay, guys. So is P is greater than alpha? Yes, P is greater than alpha. So we do not reject. We do not reject 80. So what is the conclusion then? Hence, see. By the way, so this is how you do that, right? And what will be the conclusion? Conclusion will be, I have done it here in R. Since P is greater than alpha, there are not enough evidence to reject the claim that the standard deviation of the weight of the bat is equals to 0.30. Okay, so I have done the var.test. This is the data set, bar weight, and sigma squared is the variance, 0.3 square. Okay, and then confidence level is 0.95, and alternative is two-sided. Okay, so if I run this, what do I get? I got that the sample variance is 0.0669, because sample standard deviation we found 0.2588, right? And you see that it not only find out that, it also find out the confidence interval. Okay, and look at the p-value. We got 5375 from R, and here the p-value is 5382. So they are close. Okay, so either way we get the similar p-value, and then our result or the conclusion is we do not reject the null hypothesis. See that? We do not reject the null hypothesis, and this is how you write down the conclusion there. Okay, guys, so you write down that conclusion here. Well, I can copy and paste on this, but anyway, so we do not reject the null hypothesis, then we write that hence there are not enough evidence to reject the claim that the standard deviation of the weight of the bat is equals to 0.30. Okay, guys, so this is how we test the hypothesis for the proportion, variance, and standard deviation using R. Okay, so the next thing that I wanted to discuss here is a relationship between hypothesis testing and confidence interval. I think I mentioned that earlier in the last video about this. If we reject the null hypothesis with alpha level of significance, okay, then the hypothesized value does not fall in the 1 minus alpha. If you reject, so what does that mean? That means if your result is reject the null hypothesis, then this value does not fall in the confidence interval. But if you do not reject, then this value, that null hypothesis, will fall in the confidence interval. Look at this. So the confidence interval is 0.035 through 0.16. Does this value 0.09 fall? Yes, it falls. So we do not reject the null hypothesis. Okay, if it does not fall, then we reject the null hypothesis. So that is the way that you can basically use the confidence interval to test the hypothesis. Okay, all right. So there is an example there. So it says, suppose the mean of population is assumed to be 10. So what is given? Mean is 10, mu is 10, and standard deviation is 1.5. Sigma is given. A sample of 34 items shows that mean is 13. That's the x bar. So this is mu, this is sigma, this is x bar, alpha is given there. So it says that test if the mean is bigger than 10 using the confidence interval. Okay, so hold on, it should not be bigger than, okay, there is a type, it should be different from 10. It should be different from 10. Okay guys, so that should be different from 10. So that guy should be different from 10. Okay, because we are using I want to use the two-tailed, because see here I use the two-tailed test to find out the confidence interval. So solution here, mu H0 is mu equals to that, and this should be not equals to. So mu equals 10 and mu not equals 10. Sigma is given. So 95% confidence interval, if you do that one by hand, you will get 12.496 through 13.504. Does this null hypothesis or the value from the null hypothesis fall here? No. So it does not include that hypothesized mean, meaning that so this does not include the hypothesized mean, meaning we reject the null hypothesis. Okay, so this is how we can use the confidence interval to test the hypothesis. Okay guys, all right.